Today's lesson is our first in our unit on transformations, and today we will be looking at reflections and translations. So let's first start by deciding what a transformation is. It is an operation that maps an original figure called the pre-image onto a new figure called the image. That makes sense because pre comes before. A transformation can change the size, shape, or orientation of a figure. So that's what a transformation is. There are several types of transformations that we will look at. We're going to start with a reflection. What is a reflection? Well, if a blank over a line, a flip. If we flip a figure over a line called the line of reflection, then we've got a reflection. It's like looking at yourself in the mirror. That's a reflection. Each point and its image are the same distance from the line of reflection, and we have several different lines of reflection that we will experiment with. We'll use the x-axis to reflect over. We'll use the y-axis. We'll use a vertical line, which will have the equation x equals something. We'll have a horizontal line, which has an equation y equals something. And then we'll use lines, we'll use y equals x, and we'll use y equals negative x. And both of these lines go through the origin. You just know that y equals x has a slope of 1, and y equals negative x has a slope of -1. All right, so that's a reflection. What about a translation? A translation is when I just vertically or horizontally slide a figure. And the way we represent this symbolically is like this. We go from the pre-image to a new coordinate, x plus h and y plus k, with h representing the horizontal shift and k representing the vertical shift. All right, so there's what we need to know. So let's do some examples. What I've done for the rest of this lesson is going to involve my working examples with you. And what I have done to shorten this video is I've gone through and I have sketched in all of my pre-image figures to save some time. So if you want to pause the video right now and for these next few problems sketch in your figures, that would probably be a good idea, because as I move through each one, I'm not going to slow down. I'm just going to start with the figure that I have already sketched using the vertices that are given to me. For instance, here with our triangle, we have A is -4, 2, B is 4, 7, C is 5, 1. And we have our figure there, and it says, okay, we're going to do a reflection, and we're going to reflect it in the x-axis. So what I like to do here is I'm going to sketch my x-axis in. What's the equation of this line? Y equals 0. Don't forget that. And this way, when I reflect my triangle, I can look at it and tell whether it truly looks like each image point, each vertex of my image is the same distance from that line of reflection. Okay, so what we're going to do is we're just going to move each point over the x-axis, and it's got to stay the same distance away from the x-axis. So A here is 2 units above the x-axis, so we're going to put A prime 2 units below the x-axis. B is 7 units above the x-axis, so we got to come 7 below the x-axis. 1, 2, 3, 4, 5, 6, 7. And we call our image points prime of whatever the pre-image point was labeled. And C is 1 unit above the x-axis, so it's going to come down here 1 unit below the x-axis. I'll sketch this new triangle in. And we will see that if I folded my paper right there along the x-axis, both of those figures would be right on top of each other. So what are our new coordinates? A is now -4, -2. B is 4, -7. C is 5, -1. And what do you notice about the relationship between the pre-image vertices and the image vertices? All my x values stayed the same, right? And what happened to the y values? They all became the opposite of what they were. So let's write down our little rule here so we don't forget it. Anytime we have a reflection in the x-axis, here's what will happen. The pre-image xy will change to x -y. And of course, you know you will be required to memorize all these transformation rules. Let's see what we have here in example 2. We've got a rectangle, PQRS with the given vertices, and this one we want to reflect in the y-axis. So once again, I'm going to sketch in my y-axis, which of course has the equation x equals 0. And just like we did above, we're going to take every pre-image point, we're going to move it across the y-axis, and we have to maintain the distance. So Q is 2 units to the right of the y-axis, Q prime will be 2 to the left. P is 1 unit to the right, going to be 1 unit to the left. S is 1, 2, 3, 4, 5, 6, 7. So we got to come 7 this way. 1, 2, 3, 4, 5, 6, 7. And then R is over here at 8. So we got to come all the way over here at -8. So that would be R prime. This is S prime. And let's sketch in that new rectangle that we have there. And it does indeed, looks like I got a mirror image of itself there. And what do we notice about the relationship between the pre-image and the image? Well, this time, all of our, let's see what happened here, all of our y values stayed the same, right? And it's our x values that became the opposite. So P prime is -1, 2, Q prime is -2, 5, R prime is -8, 3, and S prime is -7, 0. So that means when we have a reflection in the y-axis, we will always follow this rule that x, y will map to -x, y. And let me go back and hit a vocabulary word that perhaps I think was not on the first page. When certain transformations will be what's known as isometries. And whenever I have an isometry, that means the size and shape and distance all have to stay the same. So that's how I knew when I was going to reflect each of the two figures that I've done in a line that I had to keep each vertex the same distance from the line of reflection, because reflections are isometries, and that means I had to maintain the distance between each of those points and the line of reflection. All right, let's see what we have now. We have a square RSTU with the vertices given, and this time we want to reflect in the line x equals -1. So I'm going to sketch that line in here. Always remember that lines with equations x equals something are vertical. So now we're going to do the same process that we just did with the other two. So what I'm going to encourage you to do is pause your video. I'm going to quickly do this while you're paused, and I will come in, you'll come back in and you'll see what happens when I reflect this square across the line x equals -1. So here I have reflected my square across the line x equals -1, and the way I did that is I just counted how many units away from the line R is, and then I put R prime, the same number of distance the same number of units to the left of x equals -1, and I did that for all 4 of my vertices. And what you can see happens here is that, let's see where I am here, r prime becomes -2, 3, s prime becomes -7, 4, t prime becomes -8, -1, and u prime becomes -3, -2. All right, let's do another. Triangle STU, I have it sketched in here with the given vertices. I want to reflect in the line y equals -x. Y equals -x has the negative slope. Let me sketch that in here. Always a good idea to sketch in your line of reflection. There we go. And how are we going to figure out how to do this? Well, once again, I'm going to make sure that I maintain distance from each vertex to the line of reflection. So actually what I got to do here is I put my point on point U, and I see that to get to the line I have to go up 1. So what I want to do to get the reflected point on the other side is go over 1. So that's where U prime is going to land, right there. And I take a look at T, take a look at point T right here. I can see that I have to go over 1, 2, 3 to get to the line. So now I'm going to go up 3. 1, 2, 3. And that's going to be the reflection of point T right there. And I'll do the same thing for S. What do? I have to go over 1, 2, 3, 4, 5, 6, 7 to get to the line of reflection. So now I need to go up 1, 2, 3, 4, 5, 6, 7. So there's S prime right there. And here is my reflected triangle. And hopefully you can see that if I folded that, if I had this on a sheet of paper, if I folded it right along the line y equals -x, I would have the figure mapped right on top of itself. So what are these new coordinates? Well, S prime is 6, 1, T prime is 3, 0, and U prime is 4, -3. So let's see what the relationship is between the pre-image vertices and the image vertices. I can see that, I'm going to write my rule here, reflection in the line y equals -x every single time. Here is what happens. The coordinates are transformed as follows. xy goes to -y, -x. Because if you look at S and then look at S prime, you can see that I flipped the points, I flipped X and Y, and I also negated both of them. And the same is true for the other 3 points. All right, so always remember, guys, you got to remember these rules of transformation. When we reflect in the line y equals -x, our image points will always be -y, -x. Let's do another. I think there are actually 1, 2, 3, 4, 5. Whew, a lot more problems. I think we will maybe do one more of these, and then I will just post the solutions for the rest of them, and you can do them on your own and check your answers and ask me questions in class if you have questions. Okay, so let's see which one we have here. This is a translation, a slide, right? A translation is a slide. So I have my triangle here, and what's happening, well, remember this here is our H, and this is our K that we wrote. So I know that this means I have to take every vertex and I have to go left 1, and I have to go down 5. Down 5. So I'm going to move all these vertices according to that rule. So I got it. So let's start with S and let's go left 1 and down 5. 1, 1, 2, 3, 4, 5. So there's S prime. Let's take U and go left 1 down 5. 1, 1, 2, 3, 4, 5. There's U prime. And t is 1, 1, 2, 3, 4, 5. So there's t prime. And here's what my translated triangle looks like. Okay, and what are the new vertices? Well, S prime is going to be -5, -3. T prime will be 4, -6. U prime will be -3, -7. And guys, what you can see is, even if you didn't have graph paper, you could find what these new vertices are, because all I have to do, for instance, to find S prime is I have to subtract 1 from -4, and I have to subtract 2. I have to subtract 5 from 2, and that gives me -5, -3, which is the same thing we got doing it graphically. Sometimes you won't have a graph, so you have to understand that when I have my pre-image points, S, T, and U, when I want to find the images, I need to subtract 1 from the X values and subtract 5 from the Y values, because that's the transformation rule they gave me. Okay, the trapezoid here is just like the one above, so I'm going to pause this, fill in the answers, you complete it, and let me know if you have questions. So there's that trapezoid with that rule of transformation applied. I just shifted every vertex right 4 and down 1. Check your answer there. Let me know in class if you have questions. Let's see what we have next here. Oh, here's one. I think this will, well, no, we have to combine. So we'll do this one and the next one. Okay, so this one, they actually give us the picture of a translation, and we have to write the rule. So we know it's a translation. We know a translation is an isometry. So really, all we have to take is one vertex, and we have to find out how it was moved. So why don't we just take, I don't know, F. Why don't we just start with F here and see what happened to F? With F, we went 1, 2, 3, 4, 5, 6, 7 units to the right. So I know what my rule is here is going to be X plus 7. And how many units up did I go? 1, 2, 3, 4. So I went up 4 units. So that's it right there. Of course, you can check all the other vertices, but of course they will have the same rule applied to them because this is an isometry. All right, how do I combine? Okay, how do I combine? Well, we want to do 2 translations. So let's see, should I do this one? I'll do this one, and then you can do the last one on your own. I'll put the answer up for you. So we got a parallelogram. QRST. First, we want to reflect it in the line y equals x. So I like to sketch in my line, you know that. Y equals x. Okay, I'm going to do that first. So what I'm actually going to do here, guys, is I'm going to call that first reflection. I'm going to call those points Q prime, R prime, S prime, and T prime. And then after my second transformation, after the translation, I'm actually going to call those double prime, just so I can keep track of what I'm doing. All right, so let's do our reflection in the line y equals x. Did we get a rule? I don't know if we did one of these, but what's going to happen, guys, when you do a reflection? Rule for reflection in the line y equals x is what's going to happen is every vertex, x is going to map to y and y is going to map to x. So that's what happens. So this is going to be a simple matter. We know that q here is 2, -1, so we know that q prime is going to be -1, 2. We just switch our x and y. So -1, 2. That's going to give us q prime right there. R prime is going to be 1, 7. 1, 2, 3, 4, 5, 6, 7. So there's R prime. S prime will be -2, 6. We're just flipping our X and Y. 1, 2, 1, 2, 3, 4, 5, 6. That's S prime. And then finally, T prime will be negative 4, 1. 1, 2, 3, 4, 1. So there's T prime. So let's draw in our parallelogram here. All right, that looks good. Okay, and now what are we going to do now? We're going to translate. We're going to take our image that we just got, Q prime, R prime, S prime, T prime, and we're going to take every point left 3 and down 7. So what's going to happen when we do that is when we take all these points here and move them left 3 and down 7, we will end up with these new coordinates for the vertices. Negative 4, negative 5, negative 2, 0. So all you got to do, guys, is take these coordinates here, subtract 3 from the x value, subtract 7 from the y value, and you'll get these numbers that I'm writing in here. Negative 7, negative 6. Let me come over here and sketch that in just so we can see our final parallelogram. 1, 2, 3, 4. 1, 2, 3, 4, 5. There's Q double prime. Negative 2, 0. There's R double prime. Negative 5, negative 1. 1, 2, 3, 4, 5. There is S double prime. And finally, negative 7, negative 6. 1, 2, 3, 4, 5, 6. That is T double prime. And there is our reflected and translated parallelogram. One more problem. I want you to do this on your own now. I'm going to pause the video and I will fill in this answer and you check it out. And we'll see you next time when we talk about rotations. All right. There is the combination, translation, reflection of this original triangle that was right here, GHI. First, we took it right 7 and down 5, got this as our image, and then we reflected it in the line y equals negative 3. And remembering that a reflection is an isometry, we just moved each vertex the same distance across the line y equals negative 3 to get our final image here of the red triangle.